All right, so let's solve some radical equations. Radical equation is just an equation with a root symbol in it. Square root, cube root, fifth root, so on. All right, so let's start out with a really basic, simple one. Okay, our strategy is going to be to isolate the radical part. So I'm going to add 6 to both sides. Got that. Equals 14. All right, and I'm going to isolate the radical, so I'm going to divide both sides by 2. I get that. All right, to undo this square root, I'm going to do the inverse of the square root. I'm going to square both sides. So if I square a square root, I'll just get what's underneath it. And here I'll get 7 squared. Oh, I get 49. Right, so I squared both sides. If you square a square root, you just get what's underneath there. All right, then I'll subtract 1 from both sides. Divide both sides by 5, and I get x equals 48 over 5. All right, let's check and make sure that's really the solution. So if I put 48 over 5 in for x, 5 times 48 divided by 5 will just be 48. 48 plus 1 is 49. Square root of 49 is 7. 2 times 7 is 14. 14 minus 6 really is 8, so we know we got the correct answer. All right, let's have another look, or let's have a look at another example. So again, I'm going to isolate the radical. I'll subtract 11 from both sides. That will leave me with 3 times the square root of 7x minus 4 equals negative 9. Divide both sides by 3. I get the square root of 7x minus 4 is equal to negative 3. And then I'll try to do the same thing as before. I'll square both sides. 7x minus 4 equal to 9. Negative 3 squared is 9. Add 4 to both sides. And I get 15. No, I don't. 9 plus 4 is 13. Divide both sides by 7. I get x equals 13 over 7, and everything looks fine. Let's check and make sure that really works. Put 13 over 7 in here. 7 times 13 over 7 is 13. 13 minus 4 is 9. Square root of 9 is 3. 3 times 3 is 9. 9 plus 11 is 20. That's not 2. So let's double check. 13 over 7 times 7 is 13. 13 minus 4, that's 9. Square root of 9 is 3. 3 times 3 is 9. 9 plus 11 is still not 2. So what's wrong? So this answer is not correct. Why not? What happened? Okay, so notice right here at this step, I have the square root of something equals negative 3. So is there any number you can really take the square root of and get a negative answer? If this number in here were positive and you took the square root, it would be a positive number. If it was negative, remember you would get an imaginary number. So this step right here doesn't really work. You can't pull this off. You can't really square both sides and get a true answer. So it's important when solving radical equations that you always check your solution and make sure it works, that it's not an extraneous solution. Okay. You'll know when you're solving that, you'll see something like this that doesn't really make any sense when the square root of that's equal to a negative number. But always check your solutions, make sure they really work. All right, let's look at another interesting example. So here, if I tried to isolate this radical, I would add 5 to both sides. Then notice I have a radical on the other side too. So what I could do here is just square both sides right now. But you have to be really careful when you do that. All right, so let's try. Let's square both sides of this equation. So if I square both sides, I have to multiply square root of 4x plus 3 minus 5 by itself. So I have to multiply that. By itself, like that. And over here, if I square this side, I'll just get 2x minus 1. All right, so let's do it. Square root of 4x plus 3 times the square root of 4x plus 3 is just 4x plus 3 because I'm squaring a square root. Then multiply it by that, and I get minus 5 times this square root. Then when I multiply here, I get minus another 5 times that square root. So I end up with minus 10 times the square root of 4x plus 3. And then negative 5 times negative 5 is plus 25 is equal to 2x minus 1. Now I only have one radical left in here, so I can isolate this by itself. So let's move the 3 and the 25 to the other side. So that will leave me with 4x. And 25 plus 3 is 28. Move it to the other side. Minus 10 times the square root of 4x plus 3 equals 2x. Now I'm subtracting 28 from both sides, so that'll be minus 29. Let's move this 4x over here. So now I have negative 10 times the square root of 4x plus 3 equals, subtract 4x from both sides, I have minus 2x minus 29. And I'm going to divide both sides by negative 10. Square root of 4x plus 3 divided by negative 10. So when I divide by negative 10, I can just get rid of all these minus signs. So that'll be 2x plus 29 over 10. All right, now, this is a mess. Now I can square both sides. And I get 4x plus 3 equals, square this side, and I will get, remember I'll have to do 2x plus 29 times 2x plus 29. So that'll be 4x squared. And then 2 times 29 is 58. 58x plus another 58x will be plus 116x. I better work that out. So make sure you see what I did there. 2x plus 29. I have to multiply it by itself. So I get 4x squared plus 58x plus another 58x is 116x. And plus 29 squared. I don't know what that is, so let me ask a calculating device. So 29 times 29 is 841. This is awful. And on the bottom you got 100. All right. So notice what I have here is a quadratic equation now. Okay, so I need to get it set equal to 0. So I'm going to move the 4x over and the 3 over. But before I do that, I'm going to divide all of these by 100. So I have 4x plus 3. This is awful. I have 4 over 100, so that'll be 1 over 25x squared plus 116 divided by 100 will be 1.16x plus 8.41. All right, now I get it set equal to 0. And I get 1 over 25x squared. Subtract 4 here, so 1.16 minus 4 is minus 3.84x plus 5.41. Wow. I'm sorry, this should be a 2.84. All right, so now I have a quadratic equation, standard form equal to 0. No chance of factoring that, so I'm going to use the quadratic formula. X equals negative b, so 2.84 plus or minus the square root of b squared. So this is awful. 2.84 squared is 8.0656. So that's negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. All right, so I'm going to pause the video here and I'm going to work all this mess out on my calculator and then we'll see what we get. All right, so I talked to my calculator a little bit here, let it do all this work for me. And I got 2.84 plus or minus 2.6833 approximately right here. So this is approximately. So when I did all this, I got 2.6833 divided by 0.08, which is 2 times 125. Asked my calculator these two answers, and I got 69.04125 or 1.95875. Okay, remember when solving these, you should always check your solutions to make sure you don't have extraneous solutions. So I plugged 1.95875 back into the original equation, and it did not work. So this one is out. I plugged this guy into the original equation, and it did work. So that is the solution, the hard-won solution to that equation. All right, let's look at one more example here. Notice this time we have a cube root in here. So same procedure though, I'm going to isolate the radical. So I'm going to add 1 to both sides. That'll leave me with 5 times the cube root of 7x plus 6 equal to 10. Divide both sides by 5. And I get the cube root of 7x plus 6 equals 2. All right, to undo the cube root, I'm going to cube both sides, or raise both sides to the 3rd power. So that would give me 7x plus 6 is equal to 8. 2 to the 3rd is 8. 2 times 2 times 2 is 8. I subtract 6 from both sides. That, divide both sides by 7, and I get 2 over 7. Let's check our answer. If I put 2 over 7 in here, 7 times 2 over 7 is 2. 2 plus 6 is 8. The cube root of 8 is 2. 5 times 2 is 10. 10 minus 1 is 9. We are good.